Good morning, dear students. Today we'll start with the services which has been provided by the operating system. Okay, so keep in mind that this is the important questions which is frequently asked in a exam worth for 7 marks here. Okay, so please watch it carefully and note it down. The first and the most important service of operating system is a process management. Okay. Now, before going into detail about the management of the process, you must have to understand what is meant by the process. Okay. Now, see, a user generally performs a different type of task. That task we call it as a program. Okay. So now consider that when we wake up early in the morning and we decide to do the lots of program, the lots of tasks or many tasks during the day up to the time to go to the bed. Okay, so all those are the entities which are to be executed. Okay, so if you have a habit of noting it on a paper or in a diary, then you just note down that I have to do this task, I have to do this task, and so on. Okay, so that we call it as a program, because until and unless you execute that program, you implement that task, it's of no use. So program means when you uh, think about the computer programming. If you write a program, for example, consider the situation of writing a program in C or CPP or Java or .NET language. You write a program. So what you do? You first save it. So when you save it, it asks you the path or the location where to save, and that we call it as a file. So file is an entity which is having a location on the hard disk, and that file you store generally on the secondary memory, not in a main memory. And that file we call it as, it is a set of instruction, it is a passive entity, that is called as a program. Now when we need to execute that file or a program, we have to load it into the main memory. After loading into the main memory, then it will be given to the CPU for the execution. And when it is executed, now it no more remains a passive entity, it is an active entity. So got the difference between the process and the program? Program means a file which is stored on the hard disk, which is a passive entity, and process means the program which is loaded into the main memory for the execution. Now, which process management involves that if there are number of process, those process are kept in a queue called it as a ready queue. One of the process from the ready queue is selected by the scheduler, or we call it as a selector, and it is handed over to the CPU. So process management involves allocation of the CPU, then allocation of the main memory, the registers, and so on. So that is process creation, process whenever any type of interrupt occurs, then the process suspension, if the interrupt has been serviced completely, then the process resumption, that is the resume of the process. After all the task has been completed, then the process termination. All these are the process related operation, and in overall we call it as a process management. So just take a look or look at this. Just I told you that process is nothing but it is a program in execution. Whatever the task you decide, but out of that task which you execute, that is a process. So it is a unit of work within the system. Okay. Now program is a passive entity because it is stored on the hard disk. And process is an active entity because it is loaded in a main memory and it is executed. Now process needs the resources to accomplish its task. Now what type of resources it needs? Process needs CPU for the execution, memory to store that contents of the process. Then it requires the I/O devices to perform its I/O operation. It requires the file to store it on the hard disk. So process needs this type of resources: CPU, memory, I/O files, and so on. Okay, and the initialization of the data from where it has to start, that is the starting address of the process. Resources used by the process are released after the termination. Just I told you that after the successful execution of the process, the resources are released, okay, so that the other process can use that. Now got the concept of process management, the basic concept of the process, the program, what type of resources the process needs, and after the successful execution of the process, it releases the resource. Okay, now a process can be divided. Sometimes what happens, a process is a large, then we can't do a process, that large process at a one glance, in one attempt. So what we do, we divide the process into small tasks, and in computer language it is called it as a thread. So thread is a lighter entity, smaller entity, and process we call it as a heavy entity. Just like the process that you have to brush the teeth. So brushing of the teeth is what? It is a set of instruction, that is a process. But simultaneously you can't do that. First you rinse your mouth. So rinsing of mouth is what? It is a thread. Then you take a brush. So taking a brush is a thread. Then you brush your teeth. Brushing a teeth is a thread. So for the process of brushing the teeth is completed by small task, that we call it as a thread. Now some process may be a single threaded process, that it is having a single thread, and some process may have the multiple threads. So when there is a thread, this has one program counter. So what is the use of the program counter? You all might know that program counter is a register which holds the address of the next instruction. So process execute the instruction sequentially one at a time until the completion. The program counter will be incremented so that it will point to the next instruction, and so on. Process may be divided into multiple threads. When the process is quite large, then it will be divided into multiple threads, and the multi-threaded process has a one program counter per thread. That is, if there are 5 threads, then for the execution of the 5 threads instruction, there will be 5 program counter. So first program counter will be keep track of the next instruction in the first thread. Second program counter will keep track of the second instruction in the second thread. Then next instruction in a second thread, the next instruction in a third thread, and so on. So multi-threaded process has one program counter per thread. Now we'll see what are the operations performed on the process. See, whenever a new task is to be there, then you have to create the process. And after creating the process, when it is successfully executed, you have to delete the process. That process may be a user process or the system process. Now you may ask me the question, what is meant by the user process? User process means whatever the task you perform, that is writing a program, then using certain MS Office, using a web browser, and so on. These are initiated by the user. So we call it as a user process. Then system process means configuration of the devices, booting process. All these are the system process. Then the next operation performed on the process is suspending and resuming the process. Suspending the process when it happens while the process is executing. If an interrupt occurs, that just like that I am conducting a lecture. So my process of conducting the lecture is going on. And if someone knocks the door, what happened? That is an interrupt to me. What I will do? I have to suspend my process. Suspend the conduction of the lecture, recording of the lecture. I will just open the door and see who is there. I will give the service to the interrupt and then I will come back and then I will resume the. So similar thing happens with the process, suspending and resuming the process. Then providing the mechanism for the process synchronization. When there are more than one processes are there and they are ready to execute, they want the CPU simultaneously, then all the process cannot be given the CPU simultaneously. There must be some type of synchronization agreement that first this process will go for the execution, then second process will go for the execution, then next and next and next. It means that there will not be any attempt to access a single resource by the multiple process. The process will arrive on their different timing. So there must be some type of understanding among the process. We call it as a process synchronization. Then whenever the process needs to share the data or the information, one process has to share the information with the second has to share with the third, then there must be some type of communication among them, means the media through which they can share the information, that is a process communication. So the process management involves the operation on the process, just like this, creating and deleting, suspending and resuming, then process synchronization, process communication, and the last one is providing the mechanism for the deadlock handling. Now what is meant by the deadlock? Deadlock means if there is only one resource, just a printer is there, printer is only one printer is there, and two process wants to print on one printer. What happened? And already one process is printing on the printer, means one process is holding the printer and another process is waiting for the printer. Then the another process has to wait until the first process printing is completed. It means there is only one resource which cannot be shared. In this case, the deadlock happened. We call it as a hold and wait. One process is holding the resource and another process is waiting for the resource. Now, there must be certain type of time limit to be given, that after certain time the printer should be released so that it can be used by the another process. Similar for the execution also. So this is the process management, then the memory management. Second, so first service, the first and most important service of operating system is what? That is the process management, which we have just said. Now the memory management. Memory is the another important resource of a computer system. So it must be utilized in a proper manner. If we are working in a multi-programming environment, there are multiple programs are there. Then every program should get the space or the memory to be allocated in a memory. So what happens? Now memory management means, see, if your program is on the hard disk, will it execute? No, it will not execute. What we have to do? We have to load it into the main memory. It means you have to allocate the main memory to the program for the execution. To execute the program, we need all instructions must be in a memory. Okay. Now, all are part of the data that is needed by the program must be in a main memory. Sometimes if the program is very large, then in that case, that program is divided into parts. First part will be loaded in a memory, will be executed. Second part will be loaded in a memory, and so on. So memory management determines what is in a memory, what should be in a memory. And it optimizes the CPU utilization and computer response to the users. Now what is it means? Optimizing CPU utilization. If the program is not loaded in a main memory and you have to execute the program, what happens in that case? The operating system has to go to the secondary memory. Then it should be transferred to the main memory and like that. So that will be what? It will be a slow process. And and if the data or the program is already in a main memory, it becomes easy for the execution, means it optimizes the CPU utilization. For this, I would like to give one example that while appearing for the final exam, you are using cheats. Don't be don't feel unhappy about this, that you are using cheats. Cheats is what? Nothing but it is a secondary memory. What happens if you already studied very hard, that all the syllabus, all the contents, that syllabus contents will be in your main memory. But you cannot work hard. In such case, some people use the cheats. So cheats are nothing but a secondary memory. So if the information is already in a main memory, you will appear in an exam and you will go on writing fast, fast and fast like this, because everything in a main memory. But if you are using a cheat, secondary memory, then you have to see the cheat, you have to read the cheat, then it will be loaded in a main memory, then it will give the instruction to the hand that you have to write. So that will be slower. So if you have to optimize the brain utilization and fast access, then most of the data must be in a main memory. So memory management activities are keeping track of which part of the memory are currently being used and by whom. So which part of the memory is already allocated and to which program it has been allocated. Deciding which process and data to be moved into and out of the memory. There may be a situation occurs that some of the programs, they are unnecessarily residing in a main memory. Unnecessarily residing in a main memory. In such case, they are occupying the precious main memory, but they are not executing. In such case, those idle programs are transferred, are swapped out to the secondary memory. And those programs which are ready for the execution from secondary memory, they are loaded into the main memory. So this decision, that deciding which process or the parts thereof and data to be moved into and out of the main memory, then allocating and deallocating the memory space as needed. So these are the what is about the memory management. First thing, we have seen that whenever you have to execute the program must be in a main memory. It's of no use that it is on a secondary memory. If the program is very large, then the part of the program will be loaded in a main memory and it will be executed part by part. So when this is there, then only the CPU utilization will be more. Otherwise, the operating system has to wait. Then the memory management activities, the operating system will decide which program will be kept in a memory, which program will be which part of the memory is allocated and by which program. It will also decide that which program should be kept in a memory and program should be moved out of the memory. It also allocate and deallocate the memory space as needed. Okay. Then the third service is a storage management. Now what is this storage management? Memory management and storage management. Memory management means a primary memory where the program should reside, then only it will execute. And storage management is a secondary memory. Secondary, what is the purpose of the secondary memory? You know that there is certain limitations on our primary memory. We can't keep almost all the data in a primary memory. So in this case, in such situation, we use some diary to write down the that is the notings. So that is similar, we call it as a secondary memory. So secondary memory is used as an extension to the primary memory or a main memory, and we call it as a hard disk, and the entity stored on the hard disk is a file, which is a passive entity. Then secondary storage or hard disk is controlled by the disk controller. I told you that that is the hardware operation of the secondary this disk is controlled by the chip called disk controller, and it is operated by the software called disk driver. So disk controller is a chip, it's a hardware, and disk driver is a software. Then file system management. You know that we store the information on the hard disk in terms of file. So files are usually organized into directories. The multiple files can be grouped together into directories and access control on most systems to determine who can access what. Okay, so operating system activities include creating and deleting the files and the directories. You can create, you can delete the files and directories. Then you can also manipulate the files and the directory you can access. Then you can also map the files onto secondary storage. You will save it. Then the backup files onto stable storage media. These are the operating system activities related to the storage management. Then the mass storage management means when we need a voluminous data to be stored. In such case, the mass storage is used. Usually, a disk used to store the data that does not fit in a main memory. Also, data that must be kept for a long period of time. Proper management is of central importance. So, the entire speed of computer operation depends upon the disk subsystem, means how fast you can access the information from the that is a hard disk and an algorithm. The operating system activities related to mass storage are free space management. If there is a free space on the hard disk, how to manage it? Free space. Then if you have to allocate the memory from the hard disk, how to allocate it? That is storage allocation. Then disk scheduling. Disk scheduling means what? That there are multiple programs or files residing in on a secondary memory. Then which program will be accessed? If you have to access a particular file or a program, then how fast or which technique can be used to access the file on the disk? We call it as a disk scheduling. And this is just a migration of the data from hard disk to the register. See, this is the hard disk where the file exists. From this, you have to load it into the main memory, and then from main memory, the frequently accessed information is kept in a cache, and when it is actually executed, you need to allocate the hardware register for that. So this is the fastest one. This is slowest, then slower, then what little bit faster, and this is the fastest. So whenever the program is to execute it, the data or the information or the program must be in a register. Okay, that particular instruction must be in a register. Okay, so this is about the what it's a hard disk to register migration. Then the next service is a I/O subsystem. You know that to the computer, the peripheral devices are attached. And these peripheral devices we call it as an input and output system. Now, as per our experience, these I/O devices are very complicated in design. So, the purpose of the operating system is that it has to hide the hardware complexities of I/O subsystem or the I/O devices from the user so that the user can easily use it. So I/O subsystem is responsible for the memory management of I/O, means how the data is transferred from the main memory to the printer, that is memory management of I/O including buffering. Buffering, I told you that every device, every peripheral device had its local memory called a buffer. So memory management of I/O including buffering, storing data temporarily while it is being transferred. Then caching. Caching means what? Whenever a frequent, when we need some information in a frequent manner, then in that case, if we kept it on a hard disk, then every time, whenever it is needed, we have to go to the hard disk, then load it into the main memory, and from main memory to the cache. So it is better to store that information in a cache, that is called caching. So storing the parts of the data in a faster storage for performance. And spooling means the overlapping of output of one job with the input of other jobs. Spooling means what? Means the partially executed programs. Suppose a program is large, 50% program is executed. Then the 50% program will be what? It is spooled out to the secondary memory, and the remaining 50% program, 50% part of the program will be loaded into the main memory for the execution. We call it as a spooling. And then the general device driver interface. Device driver interface means it's software for the smooth operation of I/O devices. Drivers for specific hardware devices. So for different types of hardware devices, there are different drivers. Then the protection and the security. Now protection means it is any mechanism for controlling access of the process or users to resources defined by the operating system. We need to protect our operating system. For this we need the protection. And security means our system should be step on, and it should be built in such a manner that it should defend the external or the internal attack, just like the security guards are there. The function of the security guard is to protect the system against the internal and the external attack. Okay. Now huge range including denial of service, means whenever any service is of suspicious way, then the operating system will deny it, that is denial of service. Worms are there, viruses are there. Then if there is a method, that is a particular what activities performed to theft, that is the identity, then the theft of the service. So these are provided, these are avoided by the security. Systems generally first distinguish among the users to determine who can do that. And in operating system, every user has been given a unique identity called it as a user ID, as well as along with that the security ID is also provided. So including the name and the associated number, one per user. Then user ID then associated with all the files. Suppose this user is creating certain file, then that user is associated with all the files. Processes of that users to determine the access control. Then the group ID. Then if the users are working in a group, then that is suppose the 4 students are working in a project, then 4 students will become one group, and that will be given the group ID, and 4 students will be given the different user ID. Then privilege escalation, it allows the user to change to effective ID with more rights. Now what is meant by the effective ID? If the 4 students are working on a project, and out of that one student is a project leader, then that project leader should have that right to execute the program. So the user who execute the program should have effective ID. This is the difference between the normal user ID and the effective user ID. Got it now? Okay. So this is the privilege escalation. So that is all about the protection and the security, that is the services of the operating system. Thank you.